Okay, since the previous lesson was the law of sines, this lesson is going to be the law of cosines. Right? For the law of sines, we of course needed to have an angle and its corresponding side. So what is going to happen if we do not have a right triangle and we also are not able to use the law of sines? Well, the law of cosines is going to come to our rescue. Right? So this is another tool for our math toolbox. Law of cosines, well, we got to get a triangle up here. I can write it not one, not two, but three different ways. If I'm looking for side A or angle A, that's how I want the equation to look. If I need to find side B or angle B, that's what the equation looks like. If I need to find side C or angle C, that's what the equation looks like. Okay, so there's a couple different examples we need to look at. One of them is the situation where we have side, angle, side. Right? I cannot use the Pythagorean theorem. I cannot use SOHCAHTOA because I don't have a right angle. I cannot use the law of sines because the only angle I know is 114 degrees, and I don't know the length of the side. That's its corresponding side. So what do I have to find first? Well, let's take stock of what I do know. I'm thinking, well, I guess side A, right? Because if those are the three pieces I know everything in this equation except for the length of side A. So I'm going to plug in the values I know. Right? Grab a calculator if need be. Now here's where I got to really stay on my toes. I can add 529 and 676. What do I do next? Think order of operations. Right? I cannot do that subtracting next. I'm going to have to figure out the cosine of 114 degrees. I get negative 0.4067, etc. Now I can multiply. Negative times negative comes out positive. And now I'm going to actually end up adding 1,691.4132. Take the square root, and so A is going to be approximately 41.12679, etc. Rounded off to the nearest tenth, I get 41.1. Now, if you are really observant and on the ball, you might be thinking, wait a minute here, how could the cosine of an angle possibly come out to be a negative number? Notice the cosine was of an angle greater than 90. That is something that will be in our future. I put the 41.4 on the diagram. All right, so let's go for the law of sines because I now have an angle and its corresponding side. All right. So if I want, I can go find angle B now because I've got the pair angle A with side A. So I can plug in the values I know, use the law of sines, make sure my calculator is set for degrees when I'm doing this correctly. 23 times the sine of 114 degrees divided by 41.4, which should come up with about 0.5. Of course, I don't want sine of angle B, I just want angle B, so I have to use the inverse sine function. Calculator says, hey, it's not too far from 31 degrees. And so for the nearest tenth, I'll call that 30.7. I can add that to my diagram. Ah, easy street. I know two angles, piece of cake. I know they have to add up to 180. I can easily find that third angle. And I've got the third angle added to the diagram. Notice that I'll never have to use the law of cosines more than once on a triangle, because after I use the law of cosines, I can then move on to the law of sines. Oh, yes. How on earth could the ratio of adjacent to hypotenuse possibly be negative? Well, remember, it's not a right triangle, so there are no legs, there's no hypotenuse, right? You're used to thinking SOHCAHTOA, where cosine has to be adjacent over hypotenuse. That does not apply here because there's no right angle. There is no hypotenuse. And so in pre-calculus, you're going to learn how this works. And so, and you're going to also kind of learn what little tiny fib I just put in there. But that's something that'll be down the road. Sometimes we actually get to that in Algebra 2, but we're not going to get there this year. Okay, that we're on to say for pre-calculus. Okay, this time it looks like we're looking at side, 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 if you remember our geometric proofs. And I know all three sides, so I guess I can start for any one of the angles. But is there a best one to do? Is there a certain angle I should find? Oh, of course, angle B. Now, if you're inquisitive, you've got to be asking yourself, well, how come angle B would be the one we want to start with? Well, let's find out what could potentially go wrong with the largest angle, right? 6 is the largest side, so angle B has to be the largest angle. All right, let's take a look at the sine of 89 degrees, the sine of 91 degrees, cosine of 89 degrees, cosine of 91 degrees. Notice that if I have the sine function, I get the exact same response if I'm 1 degree more than 90 or 1 degree less than 90. But with cosine, I get different answers if I'm 1 degree less than 90 or 1 degree more than 90. That's the problem with the sine function. The sine function will not recognize if we've gone past 90 degrees. If the largest angle inside the triangle is greater than 90 degrees, inverse sine function is not going to recognize it for us. Right? If the largest angle of a triangle happens to be obtuse, the law of sines is going to fail to notice that. That's why if we are going to look for any angle using the law of cosines, if I have a choice, I will go for the largest angle first, because the law of cosines will not fail me. Okay, so let's get back to this triangle. I know angle B will be the largest angle, so I want to solve for that first. I want to use the law of cosines. Maybe angle B is more than 90, maybe it's smaller than 90, I don't know, but let's go find out. Plug in the numbers I do know. All right, 2 times 4 times 5, of course, makes that 40. But now when I combine like terms, be careful. Right, the 16 plus 25 I can combine and get 41. I cannot do 41 subtract 40. Right, those are not like terms. The 40 has a cosine function hanging onto it. So instead, I'm going to subtract 41 from each side of the equation. And now I'll say, aha! To get cosine of b all by itself, let's divide each side by -40. -5 divided by -40. If I wanted, I could put the fraction 1/8. Or if I prefer, I can use a calculator and say 0.125. I'll get the same answer either way. Inverse cosine of that answer. It gets me a shade below 83 degrees. So no, angle B was not obtuse. But I didn't know that when I started, so I want to play it safe. I want to use the law of cosines for the largest angle if I have a choice. I only need to use the law of cosines once. I can now revert to the law of sines, which is from the previous lesson. And of course, I can solve. I come out with about 41. 41.4 if we go to the nearest tenth. I can add that to the diagram. Finally, we are on easy street because I know the three angles must add up to 180 degrees. And for that, you're almost going back to pre-algebra or algebra when you know the three angles add up to 180. Obviously, that's also taught in geometry, but most students nod their heads in geometry and they say, hey, we already knew that. Okay, so another case of side, side, side. And again, why am I going to go for angle B first? Well, because angle B is going to be the largest angle because it's across from the largest side. Plug in the numbers that I do know. Do my little squaring and multiplying. Combine like terms. Again, I cannot do 85 take away 84. The 84 has a cosine of b attached to it. They're not like terms. Instead, subtract 85 from each side. Divide each side by -84. Cosine of b is going to be negative 0.4286 ... right? Inverse cosine comes up if, oh my goodness, angle B is more than 90 degrees. The law of sines would not have recognized that. Right? But now, to find angle A or angle C, I can use the law of sines. Right? So I never have to use the law of cosines more than once. Law of cosines is the creature that takes up so much room. Law of sines is from the previous assignment, so that's why I showed my work, but I didn't spend tons of time describing it because you should remember it from previous assignment. And then finally, if you know two angles, you know all three angles, and sure enough, there's the missing angle. And I can add it to my diagram. Okay, so we started out with a bunch of rocks, and here's just a good chunk of marble. And oh, let's chisel it away here. Oh, surprise, the secret messages worksheet. And here comes a more impressive pile of rock. All right, we got a nice little rock formation in the foreground. Yeah, scenic mountain range in the background. And it's probably time to try to get some work done.